So before I begin, right, while the talk is happening, we're going to have a little contest. So my team is going to give out a little MCQ questionnaire, 4 questions, and the winner is going to get $1 million like in the Chrome bounty. Right? No, he doesn't. I'm just going to give you a T-shirt. So there are 25 T-shirts which I want to give out. Unfortunately, we don't have $1 million to give out, at least not yet. So, play around in the competition. And during the talk as well, I'm going to ask some questions. And if you can answer, I'm going to give you a T-shirt. So the topic, cracking WPA, WPA2 in the cloud. And before I begin, this is what I call the shameless self-promotional side. And sadly, this is a must in most conferences. I don't expect everybody to know what we've been doing all these years. So I started off as an electronics and communications engineer, moved on to work as a developer at Cisco Systems. .1x and port security, most of the modules at that time were written by me for Cisco. After that, moved on to security research, where I discovered how to go ahead and crack web cloaking, which is an encryption mechanism currently owned by Motorola. Moved on to the next stage where I discovered an attack called the Cafe Latte attack. Gave me a little bit of media coverage. I was one of the winners of the Microsoft Security Shootout Contest, held in 2007 all over India. And since then, I've done a bunch of things. I wrote a book, has a 5-star review on Amazon, sold 13,000 copies worldwide. What most people know me for is running securitytube.net for the last 7 years. We also have trainings which now is taken by students from 75 countries. And we've started Pentester Academy, which is more of ongoing training. And we already have students, again, from around 65 countries for this offering. So the agenda for today, right? First of all, this is not a new attack on WPA or WPA2, right? What I've pretty much done is I've taken existing attacks and we've tried to leverage the cloud and see how we can do things better. Again, leveraging the cloud is not something which is new, right? A lot of people talk about, okay, you have, high performance computing, you can have machines which can do, probably 1 billion cycles a second, and we can do a lot of stuff with it. So when I do a lot of these consulting assignments or speak, people ask me for a demo. Now, how many of you have cracked WPA or WPA2? Anytime? Just 6 people? Okay, how many of you have no clue what WPA, WPA2 cracking is? Which is absolutely fine. Okay, a couple of people don't. Fine. So we look at that, we look at cloud architecture, and the tool which I'm going to be releasing, which will automate most of this. So quick overview of WPA-Personal and how it is cracked today. Right, so the user enters a passphrase between 8 to 63 characters. That goes inside a function called the PBK df2. Does anyone know the full form for PBK df2? Yeah. Okay, great. Password-based key derivation function, right? So clap, he wins the first T-shirt. Ashish, you can give him the T-shirt. And that is really a hashing function which creates a 256-bit shared key. And that key is entered on both sides for encryption. Now, again, this is a synopsis slide. If I were just to go into how WPA, WPA2 encryption works, the handshaking, right? That alone is probably a 1-hour talk. So the 4-way handshake is super simple. You really have multiple random values called nonces being transferred between the client and the access point. And using the WPA, WPA2 encryption algorithm, they end up with what is called a PTK, or a pairwise transient key. That's actually the key which is used for encryption of the current session. Now, cracking WPA-PSK, both WPA and WPA2, is pretty much still based on dictionary-based attacks. So the idea is take up a dictionary, pick up a passphrase between 8 to 63, go through the PBK df2, and then try and verify with the handshake. And if it verifies, then you know you have the right PTK. Now here's a quick question, and you can only answer this if you probably know how this works, which is we have a handshake with an S nouns, A nouns, AP MAC, and client MAC, right? That would always give one possible PTK. So how does the hacker verify that he has the right PTK? The answer is on the screen. What's that? The MIC, right? The Michael integrity check. That is what is used to verify. So I think too many people said in chorus, so nobody wins. Now, now there are open source tools available to do all of this. How many of you have used AirCrackNG? Right, okay, great. So AirCrackNG does this, and if you've tried to do it, fair enough, you can probably do 35,000 to maybe around 60, 70,000 at most on a single laptop, right? Depending on what config you have. Now, why is this process so computationally expensive? Why can we only do 100,000 at most on most machines? That's 2 on the higher side. It's simply because the PBK DF2, which we spoke about, the one in here, is actually a very CPU-consuming process, right? The PBK DF2 takes in the passphrase, the SSID length, and then goes through 4096 iterations of hashing to give you the 256-bit key, right? So every single PMK, or pairwise master key, is created only after 4096 iterations. Now, as you can well imagine, this is going to take a ton of CPU cycles, right? And most of WPA, WPA2 cracking right now is really about trying to make that process faster. Now, this is where the cloud comes in. How many of you have heard about Amazon EC2? Okay, everyone? Google App Engine? Couple more. How many of you have actually used it for something? Okay. How many of you have set up a distributed password cracker on Amazon EC2? 1. How many of you have created a distributed WPA, WPA2 cracking engine on Amazon EC2? Right? Exactly. And this is the reason why I decided to go ahead and actually create a tool for it. Now, when I used to do a lot of the talks along the way and say, hey, you know what? If you have a passphrase which is not very long, not random, then you run the risk of probably going ahead and falling prey to somebody guessing it using cloud computing. Now, the most common question I get is, can you show me a tool which can do it? Right? Fair enough, we all know we could set up 10, 20, 30 machines, probably have some sort of an IPC mechanism between all of them, and then do the distributed password cracking. But how do you really do it? Now, this is where what I've tried to do is create a full-blown architecture as well as one possible implementation of such a distributed WPA2 password cracker. This is entirely written in Python, and it can run both on Amazon EC2 as well as on Google App Engine, right? Both places. At a very high level, there are really 3 operations, right? Operation 1 is to create a large enough word list. How do you create a word list which is of size billion or 45 billion? Where do you store it? Right. That's what we are coming to. So this is really not a single machine problem anymore, right? You really cannot have your laptop running for probably a couple of years till it's going to go ahead and do all of that number crunching. So the first part is really word list generator, which then takes the SSID and goes through the PMK generator. Now, the PMK is the process where we did those 4096 iterations per passphrase SSID combination, right? Which is really the most expensive operation in this whole set. The question is, where do you store it? Now, you can store it in a file, but the problem is later on when you want to read that file, How many of you have tried to probably read a file on your laptop which has 45 billion entries? Did you succeed? Okay. Right? So what I've tried to do is make it even more scalable. Of course, you can store it on S3, you can do a ton of other things. But the problem is once you import the word list, reading it, parsing it, and all of that is going to be super memory intensive. Sadly, most of the APIs which you have may actually try to load the file first on memory, depending on which one you use. So you'll have to figure out the ones which probably can do on-disk reading and ensure they don't try to load everything in memory at one shot. So this is where I've pushed everything into a SQL database. Now, you're thinking, SQL database, right? How much memory do you think you would require for 45 billion entries? I mean, of course, each entry would be a couple of KB. Again, not scalable if you try to bring up your own SQL server. And this is where, again, we leverage the cloud. So what I've done is a simple architecture to begin with, right? You have a master. The master is going to distribute tasks and jobs. And you have a bunch of workers, right? Now, all these workers can run simultaneously on multiple machines. Now, the question is, how do they communicate? Very simply put, people who aren't familiar too much with programming, a distributed message queue. Now, if you want to set all of this up, you can use Celery, you can use RabbitMQ as the broker and whatnot. But if you want to make it really, really simple, you can just use Amazon SQS or their simple queuing system. Right? So Amazon is going to take care of the entire distributed architecture of the message queue. All you have to do is post messages in there. Those messages pretty much will live forever till you do not destroy the queue or till the time a worker picks up a job. Right? And the best part is the workers are totally decoupled from the queue. In the sense you could have 100, you could have 1,000. So Amazon SQS, you can read more about it later. The database, in the beginning you had no SQL databases, right? Very simple key-based queries, right? Put in a key value pair, again query for it super fast, right? You have the big table, which was Google's original kind of invention, which they are using in App Engine as well. But I probably tried to do something which is going to be more familiar to us all, SQL queries. Because most people do not have experience using NoSQL databases. How many of you have used MongoDB? Quite a lot. Google Data Store with App Engine. Okay, 2 or 3. Amazon RDS. Just 1. Okay. Now, what is the workflow? We have first really 3 tasks in here. Password creation, PMK generation, handshake verification, right? So password creation itself is a distributed task. Because if I want you to create 10 billion possibilities, you really cannot do it on a single machine, right? So we have a distributed password creation job. The master goes ahead and sends out subsets based on the kind of permutation you would want to have, again, based on the character set which you choose, right? And then after that, the password which is generated and the SSID is inserted into the message queue, Amazon SQS. The workers pick them up, go ahead, generate the PMK, store them back into RDS. The second part is really verification of the challenge or challenge response. At that point, we feed in the PMK handshake combination onto the Amazon SQS queue. Workers pick them up, try to verify. If they succeed, they send back a message to the master. The best part of this architecture is you can try to crack multiple handshakes at the same time. You are not really limited to just one single handshake or one single network with an SSID, right? Now, what is the biggest bottleneck? Can I create all the PMKs once and use them forever? Anyone? This is a question for a t-shirt. Yeah. Why? So the PMKs are being stored. I'm storing them so I can retrieve them back. All of them are in the database. Yeah. You'll have to be a bit louder. Can someone relay that for me? What's that? Okay, so here's the thing, right? I'm talking about PMKs. PMKs do not have anything of the nonce in them. So you can use the same PMK and use multiple handshakes from the current connection, right? The nonces will change because the pairwise transient key changes, but the master key is something which always remains the same, derived from the passphrase. It's just the transient key which changes, both the unicast as well as the group transient key, or what they call the GTK. Anyone? Okay, the go ahead. Yes, fantastic. Right, so if you look at the PMK algorithm, if we kind of quickly go back in here, notice that the PBK DF2, apart from the passphrase, also takes in the SSID. So you can clap, she wins a t-shirt. Ashish, should give it to her. Right, so after the last talk where you were being promised millions of dollars in prizes, I kind of feel dwarfed to offer t-shirts, but we'll have to do with that. So the problem really is that PMKs can be reused only if the SSID remains the same. Now, how many of you have seen your office SSID change? Every month, they change the SSID of your office network. Honestly, how many of you change the SSID of your home network every month? Right? Every week? So what I'm really trying to say is, typically most networks do not change their SSIDs, which means if I wanted to just focus on your network, then I could generate these PMKs, probably compute billions of them, store them up, and then try it against various different handshakes. And that would always probably work simply because you aren't changing the SSID. And this is something most organizations almost never do simply because it's a hassle, right? I mean, imagine you walk in one day and the SSID of your office network is changed. Everybody is going to run to the admin and say, you've changed something, nothing is working. And higher up the management, they probably wouldn't even know what went wrong. Then they think the infrastructure isn't working. So no admin would do that. So some benchmarks here based on the tool which was created. PMK generation is probably the most difficult task here. And truth be told, I've not created the most optimized solution, right? This is probably the first raw solution which I'm going to give out, and then people can improvise on it. The instance which I'm using on Amazon is the M1 Small. It has around 1.7 GB of RAM, and it has one ECU unit. So that's Amazon's way of measuring computation. PMKs is super difficult, right? It takes a lot of time. We're able to generate around 1,000 PMKs per second per instance. PMK verification with the handshake, super fast, right? 130,000 PMKs. And this required, in some ways, re-architecting the way AirCrack-NG does this, right? So a lot of code is actually borrowed in from there, which are actually C extensions which I use in Python. I ran 100 worker instances. PMK creation, if you notice, the actual cost is just 0.06 hours to run one instance. So to run 100 instances for exactly 1 hour is just $6. So really, PMK creation, 360 million per hour. The cost of startup is typically amortized. So what I've done is, people who've used Amazon, I have a custom AMI image. So the image already contains, the tool, the client-side server, which is kind of listening on a port, tries to connect back to the master, checks if everything is okay. There's a very basic heartbeat mechanism, just to ensure that if a worker goes down, I know, because If a worker gets lost, I'm actually paying for it, right? So I don't want it to be on for a couple of days and get me bankrupt, run out of money. And at the very same time, we've been storing the SSID word list combination on S3. PMK verification, that's super fast. You can actually do 45 billion verifications per hour with 100 instances. What that really means is if you spend a decent amount of time in creating the PMKs and storing them, given the SSID typically doesn't change of whichever network you're attacking, the verification phase is very, very fast. Now, keep in mind, do we need to recompute the PMKs for every new handshake? We don't. Let's say the admin changes the passphrase of the network. Do we need to pre-compute the PMKs? Why? Sorry? It's basically a dictionary attack anyway, right, to begin with. So, I mean, if it's there in the dictionary, it's going to work out. The cost of startup, again, gets amortized. And what we've seen pretty much in here is that approximately for $12 per hour, you can generate 360 million PMKs and 45 billion verifications, right? If you wanted to do a billion PMKs, it's roughly 3 times approximately, so that's $18. And the verification for a billion would be 1/45th the cost, which is pretty much, I mean, very close to really zero, right? So if you notice, the cost of verification is pretty much close to zero. This isn't any cost at all. The real cost is in here. Machine boot up. So I've used Ubuntu as the AMI. It's a very stripped down server. Pretty much it has nothing in there apart from very basic networking and all of that which is required for Amazon. And one pre-packaged service which is going to connect back to the master. And if you run this on Amazon VPS, right, they have a virtual private cloud setup which is available, VPC, then you can even do things like auto discovery. Because all of that, you could pretty much put them on the same LAN segment. You can have an auto-discovery protocol where as soon as a worker comes up, it starts sending some messages. The master can respond, right? You could do a bunch of interesting things in there. So this was with Amazon. Then the second one is with Google App Engine. Now, is anyone running a site on Google App Engine? OK. The whole of securitystube.net and Pentester Academy runs on Google App Engine. Securitystube.net is 10,000 lines of Python code, and Pentester Academy, I think, is around 6,000 lines, right? Written by me personally, every single line, with Vim, right? And it took me a long time to kind of write it, 1 month dedicated, both the sites. What I love about Google App Engine is you do not have to worry about the infrastructure. Now, in Amazon, what did we have to do? You have to decide whether you need 100 machines, 200, 300, 400. You have to ensure that those machines behave in the way you want them, which is none of them go stray, none of them become zombies. If they do, that's going to cost you a ton of money. In App Engine, you really have platform as a service. In App Engine, me as the developer, I'm not bothered whether I'm going to run 100, 200, or 300 instances, right? All I have to do is put in tasks, and based on the number of tasks, App Engine will automatically create as many instances as required to do those tasks. This is fantastic from a website scalability perspective as well. At times when people try to do DDoS attacks on us, which pretty much happens a lot, all I have to pay is probably a slightly higher bill, right? They have a ton of features, for example, automatic caching and whatnot. So pretty much most of the time, any site which really remains the same for most users, like a site like securitystube.net, just loads from the cache, right? There isn't much to do. The only time really anyone hits the app servers is when they probably post a video or want to write a comment or something like that. So the site loads super fast, simply because it runs on App Engine. Now, the architecture here, how much time do I have? OK. So the architecture here is a bit different. We have a resident instance, which is an instance always running. Unfortunately, App Engine does not allow their regular instances to do this. So you need to create what is called a backend instance, which is going to be running all the time. And that is going to be posting all of the data which is required to be crunched for the various tasks onto the queue. And then you have basically threads automatically spawned depending on the number of tasks. The instances will go up and they would pick up the task. Honestly, you could post 1 million tasks a second. App Engine has a throttle based on if you have a free account or a paid account, which is if you're using billing. And you can have them push your limits up depending on how much computation you want to do. So this is something which still working on. So finally, the tool, I've called it Chigu. It's like a funny name because that's the name of my pet dog at home. So I call him so many times in a day that I decided to just go ahead and dedicate a tool to him. What it does, it pretty much tries to automate the whole process inside out. Here is what I want, right? Most pen testers come in and say, hey, you know what? I'm not a developer. And what I really want is something which is point and click. Now, this isn't point and click because there isn't a GUI, but it's type and enter, right? It's console-based. So that's all you'd probably have to do. It automatically creates multiple instances on EC2 with a pre-created AMI, which you can download and upload to your Amazon servers. Just remember to verify it. I could have a backdoor in there, right? Just so that I can steal some of your computational cycles. So you need to probably create it yourself rather than use mine. The master comes up. You can upload a job, which can be creation of passphrases, PMKs, verification. It's modular. So if you want, you can even plug in your tasks as well. Job consists, as I mentioned, of any of these 3 possibilities. Right? So you can download the tool and try it yourself. Amazon has blocked my account because I wanted to show you guys 1,000 instances. I got my limit elevated, but looks like something went wrong, which is the code has some bugs. And they're going to shut me down, but you can download and try it yourself. Here is a sample screenshot. It basically takes either EC2 or App Engine as input. You can put the Handshake file in there. You can mention the number of instances. So I've mentioned 10. -D is you can mention a default word list or a location on an S3 server from where it can download it. And the downloading and all of that happens in a distributed way because S3 allows, in certain cases, for you to do resume, which means you can break up the list into multiple parts over HTTP itself. -S is the SSID. Put in whatever SSID you need. Length is the length of the passphrase. Right now, we are doing A to Z, 0 to 9, capital A to capital Z. You can add in more character sets and all of that if you so require, right? So it initializes the different modules, verifies the AMI. I have a quick hash check inside just to ensure that is the AMI I wanted. Somebody shouldn't have hacked your or mine account. The master boots up. You have multiple workers which come up. Each of them go ahead and report to the master. Then you download the word list. The SSIDs go in. You have the PMK jobs which get distributed. PMKs get created. Handshake is uploaded. And then the distributed handshake is cracked, right? Is there a 100% possibility you would crack the passphrase? Right? That's true for any dictionary attack. So drop me a line, vivek@securitytube.net. Tomorrow morning or maybe tonight, I'm going to make this link live, chigu.securitytube.net. You can download the code and try it. There's a disclaimer in there which kind of ensures that if there are any bugs and 1,000 machines are created and you max your dad's credit card, then that's your responsibility. Right? So I'm not going to pay for it. So ensure you read the terms of service properly before you go ahead and download and try it out. Version 1 typically March 15th, where we have full-blown integration from Amazon as well as App Engine, and highly configurable. You should have a configurable XML file which you can create and distribute. And we also plan to host this as a formal Amazon AMI available for public use, right? So anyone can select the AMI and start using it. Now, this was for WPA-Personal. How is Enterprise any different? Now, can anyone name the inner authentication protocol used in PEEP, EAP, TLS, or TTLS? Most common one, inner auth used in enterprises. That would be a bit louder. That's for a t-shirt. What is the inner auth? So EAP mechanism, what is EAP full form? Okay. So EAP is really a framework, right? You can use authentication protocols inside of it. Not in the case of PEEP or EAP TTLS. In the case of wireless, almost never. Sorry? Radius. Radius is remote access dial-in user services. That's a server. Server which provides authentication, authorization, accounting, right? AAA, as they call it. So Radius is just a server. Louder? Okay. You're very close. Very close. Little bit more. Okay, MS Chap V2. But I'll give both of you t-shirts. Ashish, so quick clap. Now here is the... Now as intimidating as PEEP looks like, and if you're interested, any of you who've never learned about Wi-Fi security, never looked into this, go to securitytube.net. I have a 40-part video series running up to 12 hours, which talks about how to create PEEP honeypots and man-in-the-middle attacks and all of that. So I'm not going to go through the whole repetitive cycle of telling you, how do you go ahead and do an MITM over Wi-Fi. But assuming you have and you can, you set up a honeypot, and you get the MS Chap V2 credentials. Cracking it is, again, very, very simple, right? It's a simple challenge response, again, based on a word list. And you can go through the entire process, just as we mentioned, and support this as well. So I have very early support. I think in DEF CON 20, a couple of people presented on, probably optimizing this even further to make it faster. I think Maxi, Morlin, Spike, and a couple of other guys presented who also have this website called cloudcracker.com. So any of you have seen this? Cloudcracker? Okay. Use this, paid for it. So you could probably do stuff, and this just allows you to do around 300 million words, 20 minutes, $17. I think pretty much using Chigu, you can easily achieve this way, way below that amount. Right? You could easily do this for way lesser. You could actually create your own site with it. All you need is a web-based front end. Remember to check for command injection if you plan to just pass the WPA handshake file name directly. Right? So, any questions about the architecture or something? Tool will be available tonight or tomorrow morning. Chigu.security.net. Yeah. Sorry?
For the storage,
yeah.
The RDS.
Yeah.
How much do you pay for that?
The storage is actually not very expensive. I don't remember the rates, but it's around 0.002 or something like that per GB of data stored. It's negligible compared to what we do.
And you don't pay for the transfer between EC2 and
that? So, very good question. So, all transfers within Amazon, you don't pay for it. So, any transfer between an Amazon EC2 instance, S3, or an RDS, you don't pay for it. So, Amazon allows that bandwidth to go for free. That's a good question, because if you had this entire setup, part of it in Amazon and part of it outside, then you'd have to pay a ton of money for the bandwidth. Bandwidth would be an issue if we had actually used TCP/IP for most of this. The best part is, because we are using Amazon's SQS, which is their own internal queuing system, the speed is mind-boggling. I think probably a couple of GB per second or something like that, which of course goes on their LAN, but they have an internal 10 gig LAN which is available, through which all the communication happens. Yeah. Yeah, that's a good question. I think the problem with Google Compute Engine, at least in the early days when I looked at it, is they weren't very flexible to have your custom AMIs kind of a thing. Right now they are. I think they are planning to do a lot of that with probably beta signups and everything going on. But in most cases, they do not allow you to really customize everything at a kernel level. Okay. You can probably choose the specific flavor you want. The last time I checked, it may have changed right now. The other inhibiting factor was that when I was designing for Google's backend servers, there were too many constraints available, right? And I did not want that I should be constrained with not installing XYZ C library and all of that, which was something very difficult for me to handle at that point. Most of the stuff which runs comfortably, at least I think 3 months back when I checked, was pure Python code or any other language which they allow. Go, PHP, what else? Java. I think they allow Java as well. So I wasn't too comfortable with that.
But it's per minute billing after 10 minutes, so
yeah,
it'll be cheaper.
Probably. Could be cheaper as well. Yeah. If they allow you to customize the AMI. I think the key thing here is I wanted the boot up cost to be very less. I did not want machines to boot up to take like 2, 3, 4 minutes and all of that. So really the image which I have is based on something called Tiny Core Linux. I don't know if any of you have looked at that. Tiny Core and kind of Ubuntu mishmashed together. So the master runs on Ubuntu while all the workers runs with Tiny Core Linux. You can play around, do some small customizations and make it run on Amazon. So the actual footprint, I think, was very, very small. I think the actual ISO itself was not even 80 MB. So the memory footprint was very, very less, so I could really go ahead and push it to as much as I could. As I said, it isn't the best optimized code ever written, so you probably have to play with that, right?